Yeah, hello and welcome to part 2 of chapter 8. Don't forget to take the notes. All right, let's continue. Although I'm giving you the notes right here, by the way, um, we're really going over the chapter in the book, but we are doing it, I'm summarizing it for you to get it straight for us. So please pay attention. Don't just take the notes out. Listen to what I'm saying. You can always pause and continue in the notes. All right, continuing with IPv6. IPv6 addresses, there are two type of addresses that you really should be familiar with. There is the link local address. So I want you to write all of this stuff down, by the way, okay? Not only listening. So the link local address is used by a host in a private LAN, just like the private IP addresses with IPv4. You cannot use these addresses to communicate with the outside world. So anything that starts with FE80/8, the first 8-bit numbers, that's really a link local address. If you want to access the internet, you want to use an address that starts with the number 2. All right, so let me see if I have, there is FE80, my link local address. I don't not have a global IP address. I'm actually using, these are the preferred IPv4. So therefore I'm going through NAT to be able to get on the internet. All right, anyway, so a domain name identifies the network. So example of the, identifies the name of the network, all right? So when you're typing www.microsoft.com, Microsoft.com is the domain name. A fully qualified domain name, you should be familiar with these because they come up on the A+ exam all the time. The FQDN, this is the full www.microsoft.com, for example, or Cengage.com. Excuse me. All right. Now at layer 4, there are two protocols: transmission protocol, transmission control protocol, and the user datagram protocol. What's the difference between them? If you are going to communicate with the outside world, most likely the data that comes from the upper layers are given to TCP for transportation, because you want to make sure that your data gets to the destination in a connection-oriented, reliable with flow control. What's connection-oriented mean? TCP, when it takes the data from the upper layers and breaks it up into segments, the first thing they're going to do, they're going to make a connection with the destination before they send any data. It's like giving somebody a phone call before you go to their house. Now, if they're there, that means you make a connection. If they respond, you made a connection, then you start sending data. You're going to make sure that it's reliable. When the data gets there, you're going to double check it. The receiver is going to double check the data and make sure it's all good. And if it's all good, then you ask for more. Flow control means that the receiver always tells the sender to either slow down or speed up the amount of segments that he needs to send, so he can control the data. So TCP is considered to be connection-oriented, reliable with flow control. All of these protocols, if you're doing web pages, HTTP or HTTPS, file transfer protocol, telnetting, remote access device, sending emails using SMTP, all use TCP protocol. On the other hand, if you are trying to upload and download files, or inside a LAN, you want, using TFTP, or inside a LAN communicating with the DHCP server, the dynamic host configuration protocol, by the way, that's what it stands for, to get your IP addresses. Or you're inside a LAN, you are trying to resolve a name from the domain naming service server, you would use UDP. UDP is connectionless. That means it doesn't make a connection. Unreliable. The receiver doesn't check the data to see if it's good or not. And no flow control. The receiver and the sender don't talk to each other to control how much data the sender has to send. All right? So that's the difference between these two. Again, write those down. Usually, if you are communicating, this is the rule of thumb. If you are communicating with the inside, you're using, inside a LAN, you're using UDP. Outside, most likely you're going to use TCP. What are port numbers? Port numbers, remember, earlier we talked about that. Port numbers identify what applications they are being used. So if you go to page, let me see here, there's a whole bunch of port numbers in here, and there they are. in Table 8.5. It's a good idea to get familiar with the most popular ones, especially if you are going to be in the cybersecurity networking field. All right, so they use the port numbers instead of the key names like SNMP or SMTP or and so on. All right, let's continue with the notes. Let's talk about the LAN infrastructure. A switch, all right, the switch that's inside the LAN. Here, this is what the switch looks like. So we need to know what the switch and the hub does. A switch is the one that connects all the devices inside a LAN. A hub in the old days, which is no longer in use, when you send data, the hub didn't know where the data goes, it sends it to everybody. But a switch, he looks at the destination MAC address, and he knows which port that MAC address is located and sends it only to that device. It doesn't send it to everybody. So a switch is the preferred device to connect devices in a LAN. This is a star topology, by the way. This is how you physically connect devices together. That's what a star topology. This is an extended star topology, or I guess maybe they call it a bus, but nobody really does that anymore. Here's a typical Netgear hub. All right, and here is, I think this is, if I'm not mistaken, this is also a Netgear hub. Here's a star topology. Here's your default gateway. So all of these users will have a default gateway here. And the switches you can, by the way, a VLAN is you can split the switch into two switches, virtual switches. That's what a VLAN is. So instead of having one LAN connected, you can create two switches. If you have a lot of ports here, let's say 24 ports, you can go in there, configure it to be two switches, one switch with 12 ports and one switch for another port. So they have VLAN 1 and VLAN 2, two switches, even though physically they're on one. That's what VLANs are, is a virtual switch. You can think of it that way. All right, so a network layer server. Well, we'll continue with that in a second. Let me go back in here. Blah, blah, blah. Okay, so let's talk about network servers. Let's go back to our notes, what I want you to write down. A network server, which includes a web server that hosts web pages, web HTML, not HTTML, pages, SMTP server, which is the server that, if you want to send emails, you are going to send them to an SMTP server. If you're going to receive emails, most likely you're going to get them from a POP server. A file server, which holds, I was writing this very quickly, holds applications for the user to use. The DHCP server is the one that assigns IP addresses. This assigns IP addresses. Let me correct that. To a host in the LAN. We discussed that. DNS is when you type in a name. The DNS server gives you the destination IP address. A proxy servers are the ones that act to do something for another server. Authentication servers, if I have a lot of people try to log in remotely, their username and password are sent to an authenticating server, such as a Radius server, if you heard of it, RADIUS. There's a syslog server. Typically, the syslog server keeps track of all the events that are happening on the network. So anybody that goes in, out, anything that the firewall blocks, denies packets from coming in, all that information goes into the syslog system. The system log server keeps, so IDS is the information, the intrusion detection system will always can check the syslog server to see if there's any alerts, any problems. Firewalls, for example, are appliances, like I said earlier, that either can permit or deny packets entrance into the LAN. The IDS, which stands for Intrusion Detection System, they are designed to detect an attack and alert the firewall to stop that attack. All right, please make sure you write all of this stuff down. An IP, write all of this stuff down too. An IPS system is an intrusion prevention system. This is even an enhancement to the IDS. It will detect and stop the attack before it enters in the LAN. A VPN, I know we discussed this earlier, stands for a virtual private network. That's the one it is used to connect hosts in a LAN uh, I'm sorry, connect a host or a LAN across the internet, I should say, in a secured manner. All right, because the internet is unregulated network. Ethernet 10 base T, what that means is the 100 means 100 megabits per second. Base means you're only transmitting one frequency, and T means this Ethernet needs a twisted pair cable. All right, an unshielded twisted pair cable. There are 7 cables. These are the most widely used cables for a wired network. There are 7 categories. The most widely used is the Cat5 Enhanced, which can handle a gigabit bandwidth, 1,000 megabits per second, and it can give you up to 1,000 meters without having a need for a repeater. You may use, by the way, the power lines at home if you don't want to use the wires as the media to connect the devices together. The only problem with that is you need to be on the same circuit. Ethernet cables also can, some switches and the NICs can offer you power over Ethernet, which means, those NICs or those switches can send you power over the Ethernet cable. So you don't need an outlet, for example, like an iPhone. If you connect the RJ45 to it, it will receive power. You don't need a power outlet then. All right, troubleshooting the wired network. So the tools that you may use the loopback plug, used to test the network, a cable tester. You'll see all these pictures in the book. All right, to determine if the cable is good, to find what type of cable that is not labeled. You can use a multimeter, Wi-Fi analyzer, tone probe to generate tones, cable stripper when you're making up a cable, an RJ45 cable, crimper, punch down tool. All right, so to make a straight through cable, I want you to follow either the T568A or 568B standard. Just remember that the 10 base T, not based, base. I don't know what the hell I'm doing here. Base T NICs, they transmits at pins 1 and 2, but they receive at 3 and 6. So when you connect a straight through cable from a host to a switch, when the switch receives the data from pins 1 and 2, it's going to send it to pins 3 and 6 on the receiver. All right. If you are going to troubleshoot a network, please follow the figure on the flowchart on page 850, which starts on page 41. All right. And follow the steps as reference. Use these steps on page 421. All of them are excellent references that you can use when you are troubleshooting a network for no connectivity, problems with the internet connectivity, if you are what TCP/IP utilities you need to use, if you have slow transfer rate, what to do, and the Wi-Fi is not working or not found, what do you do? So there are good explanations and probable causes and what you do to remedy the issues. All right. So please write all of this down. This is a summary of the chapter. And if you go through the chapter and read it, you'll be able to see everything that is in here one way or another. We mentioned it. I just wanted to go over the most important part of this chapter. There's a lot of information in here. So please, you get a chance and do sit down and read it. And again, like I told you, if you can't read it, just click in here. You'll be able to read out loud if you're too lazy to read, but at least go through it at least once. All right. So that's it for this chapter. So again, please write the notes and upload them as homework. Don't forget that. All right. Keep up the good work, guys, and I'll see you on chapter 9.